All right, we've now moved over here to page 231. We're looking at example 3, no real solution. In this chapter section 4-2, quadratic equations, solving quadratic equations by graphing. And it's interesting how they frame this example, because it's going to really kind of help us develop the mindset for a couple of things that's coming up a little bit later in some subsequent chapter sections. One of those is factoring, and another of those is imaginary number land, or more accurately described as complex numbers. And when we have no solution, what we really mean by that is when we graph the equation, we're going to find that it does not cross the x-axis. There are no x-intercepts, so therefore there are no real roots, there are no real zeros, there are no real solutions. But we're going to find when we go to complex numbers that we actually can find complex or imaginary roots of that quadratic equation. But let's first start off by what we're asked to do. We're asked to find two real numbers that have a sum of 6 and a product of negative 55. So I'm looking for two numbers that are going to multiply to negative 55, and they're going to add to 6. And so maybe I want to do a little factor tree over here if I can't recognize my multiplication tables right off the bat. And so let's see, 55. Well, the number ends in 5, so I know it's divisible by 5. So let's divide negative 55 by 5. Let's see, by 5. And if I do, that's going to give me 11. Okay, well, I got two numbers that multiply to 55, but it's got to be negative 55, which means either the 5 or the 11 needs to be a negative number. And I've got to get it to add to 6. So that means the largest number needs to be positive. Let's see, if I make this negative 5 and positive 11, negative 5, positive 11. Negative 5 times 11 is negative 55, and negative 5 plus 11 gives me positive 6. Now, I can take this information, and I'm not going to get into at this moment how I'm going to do that, but I know that if I've got two real numbers with a product of 55 and a sum of 6, I can develop a quadratic equation that is x squared plus 6x minus 55 equal to 0. And I think when we go graph this, no, it's the other way around. Negative 6 plus 55. Negative 6, got to change the sign, plus 55. Moving them from the right side of the equation over to the left. So the positive becomes a negative, the negative becomes a positive. All right, we're going to jump over here and graph this, and we're going to see what an equation looks like when it has no real solution. All right, well, we're going to now graph this equation that we did on the previous slide, x squared minus 6x plus 55. And let's see, I'm going to go ahead and enter that into here. Let's see what happens here. I think right off the bat, we probably won't see anything. Okay, so I'm going to go to zoom. I'm going to pick 0. Let me just scroll down so you'll see it. And then I know that I'm still going to make another window adjustment, but let's put this in here. All right, so I got some kind of graph. I just can't see what's happening exactly. I'm going to go here to the window, and I'm going to make a small adjustment. I'm going to change this y minimum to 0, because I'm expecting that it's not going to cross the x-axis. Let's see what, okay, there we go. All right, so down here at the bottom, that's the x-axis at the very bottom here. Well, let's make the y minimum -1 so we can see it. Let's go y minimum -1. That way we should be able to see the x-axis. Barely. Okay. And I can see that it does not cross the x-axis. And if I go into my table And I'm scrolling down for some values. Let's scroll up for some negative values. Up, we're headed to positive infinity as fast as we can go. And in our positive numbers, we're also heading up to infinity. We can see right here between 2 and 3, all right? 3 actually is our minimum value. So let's think about that. Negative b over 2a. So we had negative 6. That makes that positive 6. So the x-coordinate of the vertex is 3. All right, that's good. And then what's our equation? X cubed, well, 3 squared is 9. Minus 6 times 3, that's negative 18. That's negative 9. Negative 9 plus 55 is 46. Let's go back to our table and confirm that. When x is 3, the minimum value, the y value is 46. How about that? Shazam. There we go. But we have no real solutions. We have no zeros. We have no roots. We have no real solutions. Can't wait till we get over to complex numbers and we can find the imaginary roots. How about you? You like that idea? Probably not, but you're going to have to do it.